Hello everyone, this is Eddie the Magic Monk. We're going to continue with another complex number lesson today. And we're going to introduce to you guys the concept of conjugates. So if I give you a complex number, let's define a complex number z as, let's say, 3 plus 2i, where 3 is the real part and 2 is the imaginary part. The conjugate of z, so the symbol for the conjugate is a z with a line above it. So the line above it means that we're getting the conjugate of z. And what the conjugate is it's going to have the real part and the imaginary part. The two terms are the same, but we're going to reverse the operation in the middle to change it to a minus. Okay, so these two complex numbers are called conjugates. Okay, so if I give you a complex number and I say find the conjugate of this complex number, all you have to do is write z with a line above it, and you copy down the terms but reverse the operation in the middle. So the conjugate of 2 minus 4i is simply 2 plus 4i. Okay, now let's do a bit of exploring with conjugates and see what happens when you multiply two conjugates together. So let's try z times z times the conjugate of z. So if we multiply the two terms together, 2 minus 4i times 2 plus 4i, and using the binomial expansion, I'm just going to do it quickly because you guys all know how to do this. So you can see here that I have expanded the brackets using binomial expansion, and I've written out all the terms one by one, and the plus 8i minus 8i in the middle cancel each other out to 0. Minus 16i squared becomes positive 16 because I squared is equal to negative 1, and negative 1 times negative 16 gives you positive 16, and 4 plus 16 gives you 20. Okay, so now that we have multiplied the two complex numbers together, we end up with a real number that does not have an imaginary component. So how does this work? Why is it that when we multiply two conjugates together we get a real number? Let's try it out in GeoGebra. So I have drawn the two conjugates in GeoGebra. One is 2 plus 4i, the other one is 2 minus 4i. And if you remember, when we multiply two complex numbers together, okay, what happens is we multiply together their magnitudes and we add their arguments. So if we have a look at the magnitudes, okay, Z1, which is 2 minus 4i, has a magnitude of 4.47. And Z2 has a magnitude of 4.47 as well because they're conjugates. They have the same magnitude. So if I go Z1 times Z2, what happens is I get Z3, which is all the way over here. Ignore this dot here for the moment. Actually, I'm just going to hide that dot so we don't get confused. So we have Z1, Z2, and Z3, and if you have a look at the magnitude of Z3, okay, the magnitude of Z3 is 20. Okay, so if you type in the calculator 4.47 times 4.47, you should get 20. Okay, the next thing we're going to look at is the angle. Okay, the angle that Z2 and Z1 make with the horizontal axis, which is called the argument. Okay, so let's have a look at the angle. Let's have a look at the angle of Z2. The argument or the angle of Z2 is 63.43, and the angle of Z1 is also the same. Oops, just let me draw it the other way. So both of these angles are 63.43, but one is anti-clockwise from the horizontal and the other one is clockwise. So therefore this angle here, 63.3, is actually negative. So when we multiply two complex numbers together, we add their angles. So 63.43 plus negative 63.43 is 0. So that's why Z3 has an argument of 0. Now, if the argument is 0, it means that it is lying flat on the real axis, so it doesn't have an imaginary component. Okay, so that is the theory behind multiplying two conjugates together. Thanks for watching. See you next time.